to Dr. Nasir Mahmood, who's the Vice Chancellor Fellow, RMIT University. I will hand over to you, Nasir, and enjoy.
Thank you, Paul, for providing the opportunity to chair this session. It's a very important session, and we'll see in this how experts are thinking about the future mobility and how hydrogen can play a key role in changing the mobility of future. Without taking much time, I would like to invite our first respected speaker, Gary Knight, who is the co-founder of Horizon Fuel Cell Group and Hyzon Motors. With a handful of other investors, Carrick set up Horizon Fuel Cell Technologies in Singapore in 2003 to pursue the commercialization of PEM fuel cell products. The Horizon Fuel Cell Group is now a major manufacturer of both air-cooled and liquid-cooled fuel cells, supplying tiny, low-powered systems right up to systems large enough to power port equipments, long-haul trucks. Horizon is one of the few fuel cell companies globally who make their own MEA and bipolar plates, as well as fuel cell stacks and systems. Horizon is pushing their rapid commercialization of fuel cell electric mobility in buses, trucks, trains, and port equipments throughout the rollout of Horizon Motors, trucks, and bus offerings. Carrick has a diverse industrial background with over 25 years experience in international sales and marketing, business management, having held positions based in Australia, US, Singapore, and China before pursuing his entrepreneurial ambitions with Horizon. Craig is an hydrogen evangelist who strongly believes in the role of hydrogen as an energy carrier to address chronic problems around the world caused by the global addiction to fossil fuels. Welcome, Craig.
Can you hear me? Hello.
Yes, we can hear you.
Thank you very much. I do appreciate everybody's time, and this is a fantastic program, and we've heard some terrific presentations. So I will share my screen, and hopefully it'll work.
Yes, we can see your screen.
Okay, that's a good start because it doesn't always work. So thank you very much for the time to listen to a little bit about our story and how we fit within this context of hydrogen becoming a genuine commercial reality and a contributor to our economy and a significant contributor to decarbonisation. And I suppose the first point I will say is for some of us that live and breathe hydrogen, we don't think of a hydrogen economy as a thing. We just think that we are a means towards decarbonisation. And I think that it's important to consider hydrogen as part of a solution towards the broader decarbonisation needs rather than think of hydrogen as having somehow its own economy or its own system, in the economy. Because I just think it's not reality. We're a decarbonisation technology, if you like. So I'm going to try to make this move, and I think it moved. Can you see the next slide?
Yes.
Excellent, thank you. Just wanted to make sure it was going to change. Sometimes I've been stuck on the first slide and I'm talking my head off 3 slides in and it hasn't moved. So in summary, Hyzon Motors is this new entity of ours, and this is all about vehicles for the hydrogen revolution, or the hydrogen evolution, I guess. We've established this new business with the aim of dramatically accelerating the uptake of zero-emission heavy vehicles. So our initial deployments all target back-to-base fleets, and preferably heavy vehicles with quite high utilisation, because this provides you the most rapid payback for your investment. So the big stumbling point for adopting these vehicles is really the availability of hydrogen, and the investment in hydrogen is most rapidly justified by back-to-base operations, basically, where you need very little infrastructure to run quite a lot of vehicles. It doesn't like the arrows. Okay. So there are places where the hydrogen advantage is clear. It's not like we don't believe in batteries. We certainly believe that battery electric vehicles will coexist with others. And the more hours of operation each day, then the more likely that hydrogen to add value. In addition to the considerations here around emissions and range and and fast refueling, obviously there are grid issues associated with large-scale electrification of transport, because quite often fleet vehicles all want to charge at the same time. So you don't only have an infrastructure issue within your own, say, depot or distribution facility or whatever. You also have issues around wanting to drag an awful lot of power from the grid at one time, relay time, and then all want to charge at the same time. So hydrogen makes that a lot easier with rapid refill times. So we've created this new business on the back of Horizon Fuel Cell Technology, with 17 years of R&D in the PEM fuel cell space. We've driven a lot of kilometres on the liquid-cooled stacks, and we've manufactured about 1.5 million. So we've got quite unique. There aren't many businesses with this amount of experience and depth of IP. Our goal with this technology is to offer zero emissions combined with a competitive TCO, total cost of ownership, and I'll explain how we get there. At the moment, we have fuel cell trucks in service with fuel cell modules up to 150 kilowatts as a single module, and this has created a kind of an advantage for us in the relatively heavy vehicle space. So most of the trucks over 20 tons in service in China are using our fuel cells because of the fuel cell stacks, not that large physically, but very high power fuel cell stacks, up to 500 horsepower in a single module. So that's 370 kilowatts in a single module. So some of the applications for trucks are, concrete trucks, general prime mover applications, rigid bed trucks for heavy loads, and port trucking, for example. These vehicles we're integrating at the moment, and we'll be shipping some of these kind of vehicles especially. So what are these trucks? They're basically 6x4 and 6x2 prime movers, and they're also rigid chassis trucks with either a 6x4 or 8x4 configuration. That's describing the axles and the drive wheels for those that aren't familiar. So a 6x4 is a 6-wheeled truck or a 3-axle truck with 2 drive axles. So this group of trucks are all based on DAF chassis. So we have partnered with DAF to adapt their truck platforms to fuel cell electric configurations. So we continue to benefit from all of the various features of those trucks, like all the in-cab features and the safety systems and all the rest of it. And then we add on top of it a whole bunch of advanced telemetry, as well as the fuel cell electric powertrains and drive lines. Another product category that we're offering is city bus. Anxiety, because you have the same kind of range as you have with diesel. The city buses, they kind of look like this. This picture is really just designed to show you, what happens when you tear out an engine and you put in a fuel cell. Really, it kind of occupies the same, essentially the same space as the engine. The one thing that does have to change significantly is how you store fuel. So the great thing about using fuel cells in vehicles is that you're separating power from energy, just like you do with a traditional ICE vehicle. The power is coming from the fuel cell, so you're able to configure the power needs with the fuel cell and battery configurations, and the energy is coming from the stored hydrogen. So you're able to, configure the hydrogen storage based on what the range needs of the vehicle are. This is something you can't really do with a battery electric vehicle, because you need to increase batteries in a linear fashion to increase range capability in a battery electric vehicle. So it's really the electric vehicle and a fuel cell electric vehicle. And it's the main reason why for heavy vehicles that need to drive a lot, you tend not to use batteries. You tend to use hydrogen-based systems because of the far better weight efficiency of the systems. And we have future vehicle rollout plans from next year, which include trucks with a capability of having a gross vehicle mass of about 70 tonnes. So this serves all of the kind of B-double applications in Australia. This is again using European-built vehicle platforms with very high standards of vehicle safety, and also our remote telemetry capability gives you excellent predictive modelling capabilities and predictive and what do you want to say, proactive maintenance to ensure you don't have breakdowns and that sort of thing. And then from the second half of next year, or around Q3 or Q4 next year, we should see a truck capable road train weight, which is about 135, 140 tonnes. It looks very much like that truck is not going to be this configuration. This cab over configuration will probably stop at the B-double configurations, and we'll probably go to a heavy-duty bonneted truck style for this truck. But that's all still being finalised at the moment, because these trucks won't deliver until the latter part of next year. So what do we offer when we offer these vehicles? What are we doing? We believe we're offering zero emission with zero compromise and zero financial burden. We do that by offering a full lease package of the vehicle and the maintenance, and we can do so for modest-sized fleets, not for 1 or 2 vehicles, obviously, but for 50 vehicles or 100 vehicles. It's quite possible to have this kind of packaged offering that makes sense, where you just pay essentially like a subscription fee, pay to drive kind of thing. On the other hand, if you prefer to buy, if customers prefer to buy, obviously we sell vehicles as a capital sale, but this is all part of trying to facilitate that move to commercializing hydrogen that this seminar is all about. It's all about getting to a point where hydrogen is relevant and is contributing in the greater decarbonisation effort and the energy transition. In some cases, we can bundle fuel with the vehicle. It just depends on the availability of the fuel and who local hydrogen project managers are and how they want to supply and commercialise their own fuel. Couple of slides on what we're doing for Australia. We've set up a new Australian entity, and we are initially supporting deployments of small fleets of fully imported vehicles. But even doing this is a move towards decarbonising transport and kind of the learning process around becoming a leading player in heavy vehicle decarbonisation. And there'll obviously also be local environmental benefits every time you take a heavy truck off diesel and put it into hydrogen. And we are offering all of the hydrogen project owners a potentially high-value local demand, and this can also help to justify production programs generally. And we believe we have the chance to upskill operations and engineering type personnel, and this will be very useful skills for the future. The next phase of what we're up to here in Australia is vehicle assembly, and this starts to make sense once we have some volume flowing to justify local installation of fuel cell powertrains and the hydrogen systems. So we don't need ridiculous numbers of vehicles to do that. I would say we can readily justify a few assembly plants around Australia within the next couple of years. And obviously this is then local job creation and skill creation right through the system with this kind of program, including the refurbishment work on fuel cells, because fuel cells are fully recyclable and reusable. They don't really have a waste per se. At the end of life, you just recover the platinum and put it back into another stack and put the vehicles back on the road. So it's kind of continuous, cradle to cradle, if you like. Kind of like how aeroplane engines work. They pull them out and refurbish them and put them on another plane. And then finally, with some volume, you would actually manufacture you wouldn't only do the integration of vehicles, the build-up of vehicles from, say, knockdown kits, but you'd also be looking at local manufacture of fuel cells. And you can have a globally competitive fuel cell manufacturing base with a scale that actually matches the local market size without any trouble. And that's because the scale economies are reached at much lower levels than traditional, if you like, engine systems. And then this then underpins the local assembly of the trucks and buses, creates a whole bunch of flow-on effects, and especially creates new supply chain needs and all the rest of it. Local job creation and ongoing skill development and all the rest of it improves. And then ultimately, hopefully, you could even be a production base for export, for example. So if you're making 10,000 or more vehicle powertrains a year, you can be globally competitive with this kind of technology based on our experience. So just to close, the bottom line of what we're up to here is we're leveraging our national experience to unlock the enormous potential, we believe, for zero-emission heavy vehicles in Australia. And we think this is an important element in moving hydrogen into that commercial realm that's been talked about through this forum. And when we talk about our international experience, it is pretty significant. You know, we put our powertrains in around about 400 commercial vehicles last year in China. And we're not revealing our 2020 numbers yet, but it should be a pretty decent number in spite of COVID. So, by the end of this year, we will have a very significant number of trucks running around on a daily basis, powered by our systems within China. And we'll also have our first small fleets deployed in Europe by the end of the year. And we'll be starting the local build within the US as well by the end of this year. So that's all I had. Short and sweet.
Thank you, Craig. It's very nice talk and insightful information about the mobility of future. There's I think a lot of interest in your talk, and there's a few questions in the Q&A. Few of them are
click on the Q&A, right?
Yes, Justin, it is. They were saying someone is thinking about 300 trucks. So what do you think about the fuel cell technology for them?
So at the moment, the largest systems we are powering are train systems, electric drive trains. These are in the hundreds of kilowatts because these are just passenger trains. They're not the type of mining trains that are 3 kilometers long with tens of thousands of tons. These systems are only in the hundreds of trucks. You're going to be north of a megawatt even of electrical power for sure. The fuel cell itself is not really the constraint in moving into that kind of application. It's really the hydrogen supply from two fronts. One's the availability of that much hydrogen, but secondly, it's the onboard storage of that much hydrogen. So there are possibilities for on-vehicle cracking of ammonia, for example, to use fuel cells. And there's also on-board reforming of renewable methanol, for example. There are different ways to kind of get to that point, but we don't believe that it's a low-hanging fruit. We think that the low-hanging fruits pay for themselves very quickly, and they are high utilization, thousands and thousands of buses and trucks in the next few years, and make a meaningful impact.
Oh, that's good. Oh, thank you. And please go into question and answers tab, and please interact with the audience. I think they want to,
Sure.
They would love to listen from you. And we will move towards our next speaker.
Very good.
Once again, thank you so much for your
Thanks,
nice
guys.
talk.